Hello guys, so in this video we are going to solve exercise 11.3 of 3D geometry. I hope you have finished all the videos which I've made, so you can watch all those videos, then you can come to the exercise. It is a piece of cake after you watch all those videos and understand everything. Now let's start with the exercise. Now I want you to sit with the book so that you can see the question from the book. I will read out the question and then I'll be solving it and you can copy down the solutions. So question number 1 says, in each of the following cases, determine the direction cosine of the normal to the plane and the distance from the origin. So I have done question number 1 part A. With the help of this you can do the rest. So first thing, what is direction cosine? Direction cosine of the normal. So if you refer to my first topic in 3D video, that was equation of a plane in normal form, right? Equation of a plane in normal form. So that if you see in that, I have shown you the comparison between r dot n vector equals to p and r vector dot n cap equals to d, right? So this, if you have an n cap here, then this becomes the distance from the origin. Okay, so one of the thing which is asked in the question is distance from the origin. So by looking at this, you can understand that you have to write your equation in this form. Okay, and whereas your equation will be given in this form, but p is not our distance. Once I change this to n cap, okay, how do I change it to n cap? N cap is what? N vector by modulus of n vector, right? So if you see, I have a vector like this, n vector. If I have ai cap plus bj cap plus ck cap, right? Ck cap if I have. So if I want to find n cap, what will I do? I will divide this thing by square root of a square plus b square plus c square, right? Or I can write that as a by square root of a square plus b square plus c square I cap plus b by same thing j cap plus c by square root of same thing, right? So can you see what are these? ABC were the ABC here, A, B and C were the direction ratios. So once you divide it by the modulus of that n vector, it becomes direction cosine L, M and N. So in that question you are asked to find direction cosine. Okay, so how you are supposed to do it? Let's see. The question is given to you as z equals to 2. Z equals to 2 means what? Your equation looks like this. You remember? X plus by plus cz equals to d, right? So you can say p. Let's change it to p. So let's change it to p. Okay, now look at this. Only this component is there, z, and this is there. Okay, this you don't decide now it is the distance. No, it is not the distance. It is written like this: 0x plus 0y plus 1z equals to z. This is the form of the plane. Now if I separate this, look at this. This x, y, z is my r vector, right? And this one, and this one here makes n vector, right? And this is your p. So when you see r dot n vector is equal to p is coming, right? So this is of the form I have written here. Clear? So Now I will change it to, now this has to be divided by the square root of 0 square plus 0 square plus 1 square, because it is the normal, right? And you know that to get n cap I need to divide by the modulus of n vector, that is magnitude, so which is here. So this is equals to 1. So once I divide the n vector by 1, I need to divide b also by magnitude of n vector, which is this. So I have this divided. Now this becomes the distance and this becomes the normal unit vector. Now it's, now if you write this vector, which is 0 I cap plus 0 j cap plus 1 k cap, right? So these are what? These should be direction cosines. Previously it was direction ratio when it was n vector. Now it became, this, and this are the direction cosines. So direction cosines are this. Understand? So why we change it? We change it so that we can get the direction cosine. And while explaining, I told you that r vector dot n vector equals to p always gives the direction ratios of the plane, whereas r vector dot n cap vector equals to d gives the direction cosines of the plane. Okay, this I have already explained. So direction cosines are this, direction or distance from the origin is 2 units. Let's go to the next one. Okay, question number 2. Question number, now rest of the question apart from the question 1 you can do. Next, question number 2. So the question is, find the vector equation of the plane which is at a distance of 7 units from the origin and normal to the vector this. Okay, so let's draw the situation. It is like this. Okay, this is my xyz plane, xyz plane, and the plane is given to you like this. Plane is given to you like this. The distance from the origin, this is given to us as 7. Okay, normal to this plane is n vector given to you, right? So this is the condition which is given to you. Distance from the origin is given and normal is given. Normal can be from here also, don't worry. From anywhere you can draw the normal. Okay, now uh, you can see this is the normal. Okay, so if we have distance from the origin and we have the normal, then we know what is our form. R vector dot n vector equals to p. This is our equation of the plane, right? Or we can say, other words, this is n cap equals to d. We can say both of them are the equation of the plane, right? So we will prefer to write this one. Okay, now distance is given to us as 7. Okay, distance from the origin, check. And n vector is given to us this. This is your n vector. So once you get n vector, n finding n cap will be very easy. So you can see n vector, how do we find? Now see, this is the n cap. Okay, so and rest you will finish. So this is your n cap. This is how you find your n cap. And then you see, if you split, you'll be getting n cap like this. Now your equation is what? This. So you just put here. R is what? R is this. R you keep it as it is, and then 3 by root 70 I cap plus 5 by root 70 j cap plus 6 by root 70 k cap equals to d is what? 7. So this is your answer. Understand? So after finding n cap, you can just put in the formula, so that will give you the answer. Let's go to question number 3. Now question number 3 says, find the Cartesian equation of the following planes. Cartesian equation. We need to get the Cartesian equation. Okay. Now I am doing question number 3 part C. Okay, I am doing question number 3 part C because you can see the direction ratios of the normal are little different. Okay, so what will I do? Just to confuse you, there is no big deal. So if you want the Cartesian form ever, if you want to get the Cartesian form ever, you just change your R to this form x I cap plus y j cap z k cap. See what I have done? I have put it here, and this vector remains as it is here. Okay, so when you take dot product, you get your answer. So it's not a difficult problem. Okay, so others also you can do. Let's go to question number 4. Now see, question number 4 says, in the following cases, find the coordinates of the foot of the perpendicular drawn from the origin. Now we need to find the foot of the perpendicular drawn from the origin. This is the perpendicular drawn from the origin. We need to find the foot of the perpendicular. This point here we need to find. Okay, how we are going to find? See, this plane is given to us. Okay, so the perpendicular is falling on the plane. So I know the direction ratios of our normal to this plane. See very carefully, you see here, this is the point we require. Okay, plane is given to us. Okay, now can I say this 2, 3 and 4 are the direction ratios of the plane? Direction ratios of plane, right? But this is also the direction ratio of the normal to the plane. Yes, so that's why I have drawn a perpendicular line here. Can you see this one? Perpendicular line. This is a perpendicular line. Okay, so this is your perpendicular. Now why did I draw that perpendicular? Because these two are parallel, you can see. Okay, now let's see direction ratios of the perpendicular to the plane. As I told you that if direction ratio of the plane is that 2, 3 and 4, direction ratio of the normal is also same. So I have written here direction ratio of the normal to the plane is this. So the perpendicular is parallel. This perpendicular is parallel to the line joining the plane and the origin. Yes or no? So now you can see this perpendicular is parallel to this line. Yes. So this perpendicular is parallel to this line. Now you can see by straight lines, can I find the equation of this line? Because I have one point, equation of a plane passing through a point and parallel to a given vector. Remember, equation of a plane passing through one point and parallel to a given vector. Now this given vector is there with us. Now as you should know, that is 2i cap plus 3j cap plus 4k cap. It is given to us. Okay, now if this is a parallel vector and point is this, I can do directly x minus x1 by a1 equals to y minus y1 by b1 equals to z minus z1 by c1, right? I can write like this, so where this is my a1, b1 and c1, and x1, y1, z1 are 0, 0, 0. See, by straight line, see, this is the kind of problem you should know. Plane mixed with one more term. Okay, so by straight line, point is this and direction ratio is this, right? So I will be using equation of a line passing through one point and parallel to a given vector. So I will write like this. So this is the line equals to k, right? Now why did I take equals to k? Now see, when I equate this equation with k I get x equals to 2k, y equals to 3k, z equals to 4k. So as I change this k's, I will get different points on this line. Okay, remember, as I change my k, I will get different points on the line. Different points on the line, I will be getting different points. Okay, now if this point is lying on the plane, Okay, because we are finding the foot of the perpendicular, I want the point here. Okay, so what did I do? I found the equation of a line. Okay, equation of this line which is parallel to this vector, and then from there I found the general points on this line. By general points I mean key is there. If you change key you get different points on the line. But if you want to get the point here, okay, then k will be such that it satisfies this equation of the plane. Okay, if this xyz is lying on this plane, then it should satisfy this equation. Okay, let me remove this, all of this. So you got your point as x equals to 2k, y equals to 3k, z equals to 4k. Now if I want to find the point here, okay, then I will assume these points are lying on the plane. These points are lying on the plane. If they are lying on the plane, they should satisfy this equation also. So what did I say here? If point 1 falls on the plane, okay, this point falls on the plane, then it should satisfy this plane. It should satisfy this plane. So in place of x, I will put 2k, in place of y, I'll put 3k, in place of z, I'll put 4k. When you solve, you get k to 12 by 29. Okay, so understand something, that if I have a plane, okay, and its equation is x plus y plus z equals to 7, then all the points in this plane will satisfy this. Satisfy means left hand side equals to right hand side. If I have a line like this, 2x plus 3, okay, equals to y, suppose. Okay, suppose I have, then all the points on this line x and y should satisfy this one. Left hand side should be equals to right hand side. Okay, so that is what we are using here. If I say these points are lying on the plane, then these points should satisfy the plane. Clear? So once you get k, then you can say that for this k, because you are getting this k from the plane, with the use of the plane you are getting this plane. So you can say if I have this k, then the point will be lying on the plane. Clear? So the if you put your k value here, here and here, this will give you a point which will lie on the plane. Understand? I hope you understand now. It's clear. Well, see, the points are from 1, I put my k value here. So the points you can see. Okay, so the foot of the perpendicular is this. Understand? So whenever you ask a foot of a perpendicular question, try to find a line which touches the plane. And if you can get the equation of that line, you can get your points, because equation of a line is x minus x1 by a1 equals to y minus y1 by b1 equals to z minus z1 by c1, and you will take it as k. Then from there you can get x equals to a1k plus x1, right? So like this is in general form, but you can put values here and get that. Okay, so now let's go to question number 5. Question number 5 says find the vector equation and Cartesian equation of the plane. I am doing number A. I'm doing number A. So from the given point 1 0 minus 2, and normal to the plane is I cap plus j cap plus minus k cap. Okay, now you have seen this form. The second what we did, that this is a plane, we have a point and a perpendicular. So directly we can say that r minus a vector dot n vector is equals to 0, right? We write like this equation of that plane. So here we have the point. This will give us a vector, yes or no? And we know what is our r. R we keep it as R in vector form, and then Cartesian form we change it to this. Can you see? Okay. Now you see your equation will be of this form equal. Now we know equation of a plane passing through one point and perpendicular to given vector will be written like this. So R minus A. A, how do we write vector? Is 1 I cap plus 0 j cap minus 2 k cap, right? So j is not required, so I written it like this. Dot n vector is given to us, so this n vector equals to 0. So if you, this is your vector form, this is the first part of your question, and then if you want to get the Cartesian form, you change it to this. So once you change it, see, I have written my Cartesian form here. R I have written here, and then this is my A, this is my. If you simplify this, x minus 1 I cap plus yj, this minus is multiplied inside, so it became plus here, so z plus 2 k cap. Okay, so simplification I don't need to explain. When you take dot product of these two, you will get this and solve it within that. That is a Cartesian form. Okay, so you should not be confused, it's very easy. Thus, these things you should be clear with now after doing so much of vectors and straight line and then plane now. So it should be clear. Let's go to next question. Now question number 6 says, then the equation of a plane passing through 3 points. So now we know that the third topic in plane which we did. So we have 3 points. This is my first point A, you can see given points I have written here, and this is my B from here, this is my C from here. Okay. Now if these are point, I can get easily their position vectors. So the position vector of A I have written as A vector. You can see clearly. The position vector of B I have written it like this: 6 I cap plus 4 j cap minus 5 k cap. I don't have to repeat it again and again. I guess it's understood now. Now for the position vector of C is this, the point, you can see. Okay, now we know the equation of a plane passing through 3 points when there is an R vector minus A vector dot B vector minus A vector cross C vector minus A vector. Right, we can write like this. Okay, we can write like this. So for doing that, I need to know what is my R minus A, what is my B minus A, what is my C minus A. Now look at this. R will be some point, random point. Okay, so this is R vector. So I can say this is my position vector R. Okay, so R minus A will be what? Easily you can find R vector minus A vector. So R vector minus A vector, you'll be getting this. Okay, then you find B minus A. See this, after doing this we will get one vector. After doing this we will get one vector. After doing this we will get one vector. Okay, so when you are getting something like this, don't think that there are two vectors. After doing that operation, you will see that it becomes one vector. Okay, so I got this vector R minus A, B minus A, I got this vector B minus A vector, C minus A vector, I got like this. Okay, now I will put it in equation 1 and then I will be getting my answer. Now see, I got something like this. It's from the previous one. So from 3 and 4. From 3 and 4. Okay. Now why I'm doing 3 and 4? First I need to find the cross product. Okay. So if I find the cross product, then I will dot with that. Doing dot is much easier than finding the cross product. Right. So I have done cross product. You know how to find the cross product. If I have two vectors like this, I just take ijk and direction ratio of first vector here, direction ratio of second vector here. Yeah. So now you solve it. and then equals to 0. That means the cross product is 0. Cross product. When cross product is 0, tell me. If I have two vectors like this, cross product is a vector passing through this. Yes. So if two vectors are given to you, obviously they are not zero vectors, right? How do we write cross? A cross B vector, right? We write A vector, B vector, sine theta n cap, right? Now, suppose this is my A vector, this is my B vector, right? So if I take their cos, it will be a vector perpendicular to both of them, right? And we can clearly see that my A is not 0, B is not 0. So how can their cross become 0? It can become 0 only when theta is 0 degree, because sine 0 is 0, right? So this cross has become 0 because the angle between A and B is 0 degree. 0 degree means what? A and B are lying on the same line. A and B are lying on the same line. Clear? So if A and B are lying on the same line, you see 3 points here, 3 points which we took, this one and this one and this one, all are lying on the same line. This one and this one. If they are lying on the same line, okay, then you can say they are collinear. If they are collinear, we will not have equation of a plane. Clear? So here I can say that if I put this 0 here in this, the points are, this whole thing will become 0 and then the point will be collinear. Now 6 part B also I am doing, because 6 part 1 was a little different. There we saw that the 3 points are collinear. So if I already told you while explaining the topic that if 3 points are collinear, then we can have millions and millions of planes through that line. Okay, so we cannot get the unique equation of a plane from there. Okay, so you can just say they are collinear. If they are collinear, then many planes can pass through that line. So we will not get a unique plane from there. So that's why I'm doing this 6B again, 6 part B. The 3 points are given to you. Okay, so we know that this is the equation of that plane, which passes through these 3 points. So you have R as this, A as this, A is this, B is this, C is this. So I'm finding R minus A first. Yes, B minus A, which is this, C minus A, which is this. Okay, you know how to find. And then from 1, 2, 3, and 4. 1, 2, 3, and 4 I do this. Okay, previously I found out this cross this first. Okay, this cross this I found. That is one way. You can find this cross and then take dot. That is one way. Another way is directly scalar triple product. Scalar triple product is the third time I'm mentioning. In scalar triple product, if you just write the direction ratios of this one here, direction ratio of this one here, and direction ratio of this one here, and then solve the determinant, you will get the answer. Okay, so see the one vector dot, second vector cross, third vector. So that is scalar triple product. Scalar triple product will be solved like this always. So now when you solve this, you will get the answer like this. Okay, so I don't need to explain these steps. Let's go to next question. Question number 7. Question number 7 says, find the intercept cut off by the plane. This. So the plane is given. We need to find the intercept cut by this. So we have already done intercept form, right? We have already done intercept form. This is my XYZ plane. Okay, so this is the plane. This is intercept form, right? And how do we keep that plane? I already told you. So this is how we kept the plane on the XYZ plane. So this place is the intercept, these places are the intercept, right? So now intercept form, now I divide throughout by, because intercept form looks like how it looks like x by a plus y by b plus z by c is equals to 1. It looks like this. Okay, so I will first refer to this part. So here I need 1. So to make this 1, I should divide by 5. So I will divide throughout by 5. Okay. Now in intercept form, x does not have a coefficient, y does not have a coefficient, z does not have a coefficient. So this 2 comes down. It will be 5 by 2. It will be 5 by 2. And this is 5. This is also, this minus comes down because this is plus. This is plus and this minus 5 will come down. So intercept on the x-axis is a, intercept on the y-axis is b, intercept on the z-axis is c, right? So similarly, you can see this part a, b, and c. So these are the intercept. Okay. If you have gone through the topic which we have done before nicely, these will be very easy for you. Go to question number 8. Question number 8 says, find the equation of a plane with intercept 3 on the y-axis and parallel to the z or x-axis. Okay. So here see the intercept of plane on the y-axis. This should be y. On the y-axis is 0, 3, 0. That means there is no intercept on x and y-axis. So you can see this is my x. This is my axis, and the plane is passing through y-axis and parallel to z o x plane. Okay, according to the question, parallel to the z o x plane. So if it is parallel to the z o x plane, so it is not touching the z-axis, it is not touching the x-axis. That means the coordinates of x and z should be 0, and if it is cutting the y-axis here, it will be only this point. So if it is not touching, I will not have my x part, I will not have my z part. Okay, don't confuse with this. You will not write x by 0 plus y by 3 plus z by 0, 0 equals to 1. Don't take this one. Intercept form is written with this point as well as this point, but they are not touching. That means this part will not be there, this part will not be there, only this will be there. So that's what I have written. Y by 3 equals to 1 and y equals to 3. So that will be your intercept form of this plane. Let's go to the next question. Question number 9. Now this is an important one. Question number 9 says, find the equation of a plane passing through the intersection of the planes phi 1 and plane 2. Phi 2 is this. So we represent our planes as phi 1 and phi 1, phi 2, pi. Okay, so don't get confused if you see pi written on your diagram or in the solution of a problem. Okay, so pi represents the plane. So pi 1 is my first plane, pi 2 is my second plane, and it is passing through this point. Okay, suppose I have a plane like this. Okay, I have a plane like this. I have another plane like this, and I have third plane like this. Okay, now they are saying this plane and this plane is given to me, pi 1 and pi 2. Pi 1 and pi 2 is given, and then I need to find the equation of a plane passing through the intersection of this and passing through this point. That means on this plane, this point is lying. This point is lying on this plane, and this plane is passing through this line. So you should be clear to you. Okay, now we know that the equation of a plane passing through the intersection of two planes, pi 1 and pi 2, will be written like this, right? Pi 1 plus lambda times pi 2 equals to 0. This is the equation. Okay, now let's write down those equations. Now you can see I have written the equation here, 3x minus y plus 2z minus 4 plus lambda times x plus y plus z minus 2. These are our two planes. So once you write it, so you solve it. Once you solve, you will get an equation like this. Okay, so you can use this equation also. Okay, You can see there is 1 missing here. 1 you can write. Okay, 1 minus lambda, because you can see clearly from here. Okay, so now 1 minus lambda. So this can be used, or you can use this equation. 1 2 you can use. Okay, so now if it is passing through this point, now this plane, I already told you that it passes from the line and it passes through this point also. So if this point is falling on this plane, then it should satisfy this plane. Clear? So my problem is lambda. I need to find my lambda. So I am putting this. Yes, yeah, I put 2. It should be 1 here. Then 2, and this is 1. Okay. So now if you multiply this 6 plus 2 lambda minus 2 plus 2 lambda plus 1 plus lambda, if you multiply you will get, so solve, you will get lambda as minus 2 by 3. Okay. So once you get lambda equals to minus 2 by 3, you can put here or you can put this here, whichever way you want. Okay, substitute and then solve and get the equation here. So that calculation I'm leaving it to you, because I have already done this explanation in the previous video where I have explained the topic. So I have explained the topic, equation of a plane passing through intersection of two planes. Okay, and then I have solved the question. So you see there. Next question 11, which says question number 10, exact example I have shown you in that video. Okay, in that topic, I explained the topic in that video. So you can see that and solve question number 10 yourself. Question number 11 is little different, so I want to do that here. So they are saying that find the equation of the plane through the line of intersection of the plane, this one and this one, which is perpendicular to this one. Now you see, if you have two plane like this is the intersecting line. So from here, if I say my plane is passing, this is my plane passing, this pi 3 will be perpendicular to this plane, required plane. So if these two are perpendicular, their normals will also be perpendicular, right? Yes. If their normals are perpendicular, their dot product will be 0, right? N1 vector N2 dot should be 0, right? So this might help us in finding lambda. Where the problem in this kind of equation problem is finding lambda. So this can help you. Okay. When you find this plane, this one, and you know this is perpendicular to this, you can use that. Okay, let's see how we solve. We know that the equation of a plane passing through the intersection of phi 1 and phi 2 is lambda 1 plus pi times lambda 2 equals to 0, right? That's what I have written. So lambda 1 plus pi times lambda 2 equals to 0. So when you put it here, you will get your equation like this. X you combine, y you combine, z you combine, you get this. According to question, this equation is perpendicular to pi 3. You can see here what I have drawn here. See, this is what we have found now, just now number 2, and these are given pi 3. So they are perpendicular. Okay, let's see, direction ratios are given like this. This number 2 and direction ratio of pi 3. See, the direction ratio is 1, minus 1 and 1. So those are the direction ratio of the normals also. Okay, so if they are perpendicular, if the if the planes are perpendicular, okay, then what do we have? This condition will be satisfied if the planes are perpendicular. If the planes are perpendicular, their normals will also be perpendicular, and n1 and n2 are normals. So if n1 is a1 I cap plus b1 j cap plus c1 k cap, and n2 is a2 I cap plus b2 j cap plus c2 k cap. So if they are perpendicular, what do we write? a1 a2 plus b1 b2 plus c1 c2 is equals to 0. Yes, it comes from the angle between two planes. So you take the dot a1 a2 plus b1 b2 plus c1 c2 equals to 0. Then lambda will be this, and once you get your lambda, you substitute here. Okay, and then you get the answer. You can substitute here, or you can substitute in this one also. Okay, one or two, whichever you feel like. So now see, I have substituted in 1. Wherever you find it easy to solve, you substitute here. So this 1 by 3 will be, I take LCM for all of them. Okay, so this 3 will be multiplied here. So with 3 multiply 3 here, you will get 3x plus 3y plus 3z minus 3, and minus sign will be multiplied inside. You get this 3y will get cancelled. You can say this, and this will give you x. This will give you minus z. This will give you minus z, and this give you plus 2. You can take it on the other side, your wish. Okay, so this is question number 11. Let's go to question number 12. Question number 12 says find the angle between the planes whose vector equations are this and this. Okay, so vector equations are given. If I need to find the angle between two planes, I just need to find the angle between their normals, which I have explained. So see, this is the normal for the first plane, this is normal in the second plane. Just use this. Okay, I hope you remember this. You just substitute, you will get the answer. Okay, so next you can see I've substituted here, and then when solving it, so your answer should come out to be this. Okay, it's very easy, we have done many previously also. Now let's do question number 13. Question number 13 says that in the following cases determine whether the given planes are parallel or perpendicular. If in case they are neither, find the angle between them. So first you need to check for parallel, then you need to check for perpendicular. If they are not both, you find the angle using cos theta. So this is my plane. Yes, can you tell me what is my n vector from here? From here, can you tell me what is my n2 vector? It will be 2i cap minus 2j cap plus 4k cap. And from here will be 3i cap minus 3j cap plus 6k cap. Right? So a1, b1, c1, a2, b2, c2 I got from here. And for parallel, this was the condition we have already derived. Because the ratio of the direction ratio should be equal. If they are equal, you say they are parallel. If they are not equal, you say they are not parallel. So you put the values, you will see that they are equal. So this planes are parallel. So you don't need to find the angle. We know 0 degrees between them. Next 13a. I did 13c first. Now 13a. Now 13a. First you check for write down your n1 vector and n2 vector. You write down from there a1, b1, c1, a2, b2, c2 you will get. Now check the ratios, they are not equal, so they are not parallel, right? And then for perpendicular case, this is the case perpendicular, right? So you check it is minus vertical not equal to 0, lines are not perpendicular, so I need to find the angle between them. Okay, so cos theta, this is the Cartesian form which I am taking from a1 I cap plus b1 j cap plus c1 k cap a2 I cap plus b2 j cap plus c2 k cap, right? So if you take dot, you will get this, and divided by the modulus of this, you will get the answer. So this is how you are solving. You get the answer easily if you pause and copy. Now the last question. Okay, last question is also important. So the last question, in the following cases, find the distance of each of the given points from the corresponding given plane. Okay, so this is the distance of a plane from a point. Okay, so this is our given plane, this is our given point. So we know the distance from the point of a point from a plane. We already know how do we write. We write like this, or we write like this. Clear? One more form is a vector dot n cap minus d, or a vector dot n vector minus p by, right. We can do both of them, but r we will be using mostly. Okay, and our given plane is like this, so we separate it and we write it like this in the form of r dot n vector minus p. So this is my r, this is my n, and this will act as p. Clear? Now d. So when you do r dot n, when you do r dot n, when you do r dot n, this one, you will get this one back, right? So in place of this, I will directly write this part, and minus p, I will write minus 2. So see what you are getting, 2x minus 3y plus 6z. I am not taking dot again, I am just writing the given plane. Okay, and minus p, and divided by the magnitude of the normal vector. Normal vector. See, so whatever is n, I will find its normal vector. So these are n. So n modulus of n vector will be 2 square plus 3 square plus minus 3 square plus 6 square. So now see, I've done it here. Divided by root 14, and root 14 is 7. So this is minus 14 by 7. Modulus will remove the minus, and it is 2. So this, now you can do the rest of the problem in 14, 13. Okay. So this completes our plane 3D geometry. Sorry, 3D geometry is finished. Now next I will be starting with calculus. Okay, calculus starting from limits. Okay, thank you.